Okay, so welcome you all to the fourth day of our workshop, and today we are going to go to the remaining part of the image processing section that we started yesterday. And also we will start after finishing this, we will start the machine learning with Python topic, and then we will discuss the things that we need to create a machine learning model and how to train it, how to evaluate it, and finally, how to get a machine learning model and integrate it in a web application or a mobile application. So today and tomorrow, the last 2 days of our workshop, we will be basically discussing about machine learning and machine learning model deployment, right? Okay, so first, today we will complete the remaining part of the image processing section. And as usual, if you have any doubt or any concern, please feel free to always ask those questions. I'm happy to answer those questions, right? So yesterday we started the image processing section and we got to know basically what's an image. And we then discussed the three main types of images available in computers: color, gray, and binary images. And thereafter we got to know that an image is a Numpy array. Simply, if you use OpenCV, image is loaded into a Numpy array and a 2D-dimensional array, right? So we got to know how to load the image, and thereafter we got to know how to access pixels, right? Pixels, how to access pixels. And thereafter we discuss about how to load videos, and thereafter after loading a video, right, we first load the single, we loaded a single frame, and finally we included the same code in a loop and obtain the how to load it continuously, right? So that's what we did last time, and we finished basically these things, right? These things. Okay, so didn't you got the didn't you get the uh, the recorded video for the tutorial, the Numpy tutorial?
No, they only uploaded the day 3 yesterday's recorded session.
Okay, so it's the same for others as well?
Yeah, we need to sign into the portal and check up the videos, the recorded sessions. But in the recorded session only, you told now that they will be separately sending the CSV related.
Right. Um, so he told me that it's done, and yeah. Anyway, let me give me a second. So,
I called them. I called them. After calling them, they are telling we
some
uploaded
of them say that it
Numpy.
is there.
Numpy. They're telling it is Numpy Matplotlib is there. They're
Yes.
telling like that.
Yeah. So
Only specifically, I am unable to find CSV.
okay. Okay. Give me a second. Um, all right. Yes. Yes. So yeah. Now, you got the basic Python tutorial, right? The Python basics tutorial. In that, you will find a video called, I can't remember, but answers to the MATLAB, answers to the Numpy exercise or something like that. So you
Yeah,
got
it
the,
is there. Modules are there.
yeah, in the modules
But
tutorial, the video is there.
okay, I will find.
Okay, right. So now, then we move on to these pointwise operations, right? Pointwise operations or pixel operations, right? And we got to know that there are different methods of loading images, right? You can load it as a gray image, and you can convert it to, if it is color image, you can convert it to gray and load, or if it is a color image, you can load it unchanged or as a color image. So unchanged is simply like if it is having alpha component, that means it's a transparent image, there will be 4 components, right? Then we discussed about color spaces changing, right? So how to change a color space and from already existing color space, right? So that's what we discussed under this one, how to convert a color image to gray and gray image, I mean, RGB to BGR, BGR to RGB, BGR to gray, and BGR to HSV to BGR, BGR to HSV. Likewise, we discussed about this is the function uh, that we can use for color conversions, right? Color conversions. Got it? Right. So then the topic today that we are going to start is image thresholding, right? Image thresholding, right? So image thresholding is simply uh, a method used to convert a gray image into a binary image, right? A gray image into a binary image simply, right? So when you have a gray image, using these thresholding methods, we can convert it to a binary image, right? So there is a very simple method of doing that, and it's a very standard, I mean, very straightforward method, right? So there is a image. I will show you how to do this, right? So anyway, the thing is like the objective is to, okay, let's say that if you have this kind of image, right? So the objective is to convert it to this form, right? Gray to binary, right? So you may be wondering why this is required, why we need to convert gray into binary. Is there any specific reason? Yes. After converting a gray image into a binary image, we can do lots of things, right? So we'll discuss about them later, but it's quite important. That's why we are trying to like convert a gray image into a binary image, right? So let's see how it's done. What you have to do is uh, get the image, right? So let's load the image. Now there's a threshold image called threshold.jpg in the samples folder. You can check it, right? So samples folder. Yeah. So yeah. So samples folder. This is the image that I'm talking about, right? So I load it here and I show it using the pld.imshow function, and you will see this kind of image, right? Got it? So then the task is to convert this into a binary image, or we can say it's a kind of a black and white image, right? So this image, what's the specialty about this loaded image? Can you see now? It's kind of a image where a column represents a color, right? So the first column, right? So can you see now here? The first column is like 0, that means black. This row is like, I mean, the second row is like 1, 2, 3. I mean, one column represents a color, a gray color, right? So finally, at the end, what you can see is like 255, right? That's white. I mean, that's white, right? That's white. So starting from 0, right? Starting from 0, it's going up like 255. So it's like having color, uh, right? Color columns, right? Color columns. So each column represents a color. Can you understand, right? So it's color strips. It's like color strips, right? You got it? So that's what you can see here, right? This is not a special image, but right. So we have a function in OpenCV called threshold, right? So this threshold function is used to convert a gray image into a kind of a binary image. So here what we can do is we can, first parameter that we need to pass to threshold method is the source image or the input image. So we pass this image, right? And these are like two important parameters you need to provide. So this is the threshold value and this is the upper value. So what happens now? Yeah, I will explain about these two values, right? And this is the thresholding method. So we have several thresholding methods like thresh binary inverse, thresh binary trunc, to zero inverse. Likewise, we have several thresholding methods. So we have to provide what's the thresholding method that you are expecting, right? So that's what we have given here, the thresholding method. Got it? So what happens is, once this image is given, it will be converted to a black and white image using threshold binary method. And these two values, like they act like this, right? So all the pixels in this image, which has a value greater than 20. The pixel value, I mean by the color, right? The color. So you know, in a gray image, we have 0 to 255. 0 represents black, 255 represents white, right? So all the pixels which has a value greater than 20 becomes 255. All the pixels that has a value greater than 20 becomes white, becomes 255. Got it? Understood. So this is the resultant image that you are going to get, and this red is simply a binary value like 0 or 1. But this is the resultant image that you are going to get. So if I plot it, you will see something like this. See? Now what happened? Now I told you that these are kind of color strips, right? Here in this image, I mean this example image is like color strips, right? So you can see all the see all the values greater than 20, the pixel values greater than 20, right? They have become white. Got it? Question, let's see. Can you change it from 20 to 50? I think don't. Yeah, I can't. No, you can't do that. You can what you have to do is you have it's binary, no? So then either black or white, right? So 255 that means it is white. You can't give any intermediate value here. No, right? So here you can see okay. Yeah. Yeah. So let's see. See? Now what happens? Right? All the pixels which has a value greater than uh, 50, now they become 255, right? Now don't get I mean don't get this misunderstood, right? So here this represents the number of the rows, right? Now this represents height and this represents width. Sorry, height and width here. Got it, right? So these numbers are not pixel values, right? These numbers are not pixel values. They show the resolution of the image, right? Resolution of the image. But I'm talking the color 50, the gray color 50, right? So all the pixels which has a greater value than 50 now becomes white. Got it? Right? Understood? So now what happens if you increase this, now all the values greater than 200 becomes, right? Got it? Right? So this is what happens. Right? So now, yeah, right. So this is the other method of doing it, right? Thresh binary inverse. So inverse is the inverse of it, right? Now you can see we have, okay, let's say 120, you are going to get an image like this. So if we apply the same value and if you change the method cv.thresh binary into cv.thresh binary inverse, the invert of that image will be given here. Can you see? Right. So now the other method is to zero, right? So what do you mean by to zero? The other thresholding method to zero. What do you mean by to zero? Can you see? All the gray values greater than 255, sorry, all the values greater than 120 remains as it is. See, all the values greater than 120 remain as it is. They don't, like, they won't become white, but they remain as it is. They remain in their original pixel values, right? But all the pixel values less than 120 becomes black here. Understood, right? So that's the to zero method, right? To zero method. And the trunk method is the other way, right? Other way in the sense, yeah. So you can see all the pixel values greater than 120 become 255. That means they become white. All the pixel values less than 120, they remain as it is. See, they remains in their original pixel values. See, can you see it? So they remain as it is, but the values greater than 120 become white. Got it? Right? Understood. Right? So different thresholding methods. Right? So now let me show you, in order to understand the usage of it. Right? So let me show you this example. Right? So there are a set of coins available here. Can you see? Right? Right? So this is the gray image.png, gray image.png. So when I load it, you can see this kind of image, right? So I load it and I show it simply, right? So let's say that we want to detect, right? We want to detect these coins, and if we want remove the background and extract the coins only, right? So in that kind of a purpose, we can use thresholding methods, right? Got it? So can you see now first we will now okay, so let me use like 200. So right, so if you use 200 and I give this image 200 and 255 and I ask like 3.thresh binary, right? So what it means now, the coin image, all the pixels greater than 200 should become 255. That means they should become what? White. But you can't see, even like you can see, I think a single kind, several small tiny little pixels. Other than that, all the pixels are black, right? So that means what? This thresholding, the value that we have given, is it too high or too low? What do you think? The objective is to extract the coins. The objective is to extract the coins. Yes. the thresholding value. We have given like 200. So we asked to like convert all the pixel values greater than 200 into 255. That means we have asked to like convert all the gray values greater than 200 into white. But we can't see any white pixels here, right? Only few. So what's the, yeah. So the value that we have given is too high actually, right? So let us, that's why you can't see any white pixel here, right? Okay, now like it shows you something, right? Okay, 100. See? Now it shows you something, but not all the coins, but some parts other than the coins as well, right? So that means, okay, so in this one, what do you think? In order to detect coins, I mean, in order to detect coins clearly, what do you need to do? Do we need to make this? I mean, do you need to decrease this threshold value or increase this threshold value? Yes. What do you think? Yes, you have to decrease it, right? So, I mean, I have done this earlier, so I know like kind of a value 80 would give you a perfect result, right? So now what's the idea here? All the pixel values greater than greater than 80, they become white. They become 255. Others, right? Other pixels become black, right? So since you have like kind of black pixels here, I mean black pixels in the coin, so you can see the coins are black and all the other pixels has become white. So we have extracted coins here, right? We have extracted coins here. Right?
Excuse me, sir.
Yes.
What is the significance of using CMAP equal to gray in all the scripts?
This one.
CMAP is equal to gray.
Yeah. So the thing is now when you show,
yes, in every code.
Yeah, when you plot the image using this matplotlib.imshow, by default it shows as a color image, right? So what I mean, the color image in sense, this makes no sense, but if we open the pld.color bar, now this is something that you need to do if you show the image using matplotlib, right? So if you use the cv2.imshow, this is not necessary, right? This is not necessary. So here can you see now this is, I mean, this CMAP parameter should be provided only if you are doing it in Matplotlib, right? Otherwise, it's not required. It will show like a normal image. But Matplotlib, by default, it gives like, it shows this image by assigning a color for each pixel value. So like, no matter it's a gray, it shows according to this color bar, right? So the pixels were like value 0, this like this, right? Likewise, it assign these colors and show this, right? But if you provide CMAP gray, right? If you provide CMAP gray, what happens is that it converts it to gray like this. So now it's assigned like this. Now, this is not something with the image, but it's something that the Matplotlib does, right? So it assigns a color and show it the image. But if you want to get the gray color, you have to pass this parameter, right? So now, I mean, if you use the cvd.imshow, right? It's not a issue. See, now when you use OpenCV, it's fine, but there is an issue with the, not an issue. That's the default setting of Matplotlib. It assign a color value
Okay.
itself and show you the image, right? In order to show the
Okay.
right, in order to
So,
show the
so every time the color can get changed. I mean, the assigned
yes,
colors can get changed, or
yeah. So they sometimes they become random values. Uh, no,
okay, okay,
actually, anyway, it lies in this range, 0 to 255, and you can change this color map as well, right? So there are several color maps available in the. Uh, it's not available like RG, but
okay.
uh, here these are some color. Uh, like let's say rainbow, right? So there are several nice color ranges available.
Okay, these are the colors. Okay,
Yeah.
okay.
Okay. Right. So then I think you would understand that,
Okay, sir.
right? Yeah. So here now important
I
thing.
have a question.
Yeah, thank
So I
Yeah.
have a question.
Yeah.
Is there a difference, or is there advantage or advantages over Matplot library for image show and CV2?
Yes. Actually, the thing is now why I use this is this. If you use OpenCV, it opens a new window, right?
Okay.
And also the advantage here is using Matplotlib that it shows the
Scale.
resolution, the row number and the column number, everything,
Mhm.
right?
Oh, that's
And one important thing, uh, this enlarge the image, right? Enlarge in the sense like, for example, let me show you now. Let me create a copy of this one, not this
okay.
one. Um, um, yeah, this one is fine. Yeah, let's say this one. Okay, so I'll create a copy of this image.
Yes.
All right, so let me now, I think it's a high resolution image. Let us check, not high, but yeah, 500 into 500 roughly, right? So let me using paint or something, let me, yeah, let me reduce the resolution. So now this image is somewhere around yeah, 26 into 27, right? So very raw resolution image, right?
Yeah.
So now, I mean, if you have a low resolution image, let's see. Now I'm going to get the image loaded here, let's say. Right. So let me open the image using OpenCV.
Mhm.
Right, so you can't even see the image, right? So it loads it in the actual resolution,
Resolution, yes.
right? But if you load it using the PLT or show it in PLT, right? So it enlarge the image and show you, right? So I mean, enlarge, you can't see the image, but it enlarge you and show the image so you can see a clear picture here, right?
Yeah.
So that's one advantage. And
Okay.
but unfortunately, you can't run a video using plt.imshow.
Oh.
That also
So
can be done.
use CV2 only.
Yeah, that also could be done, but it's a very hard method to do. But OpenCV in that case, load videos, OpenCV is good.
Okay.
Right. So can you see now here, very important thing, right? We use the trunk method, right? So can you, so not this one. Yeah. So can you remember the trunk method? What do you mean by trunk here? So can you remember the trunk method? Right. So in trunk method, all the values less than 120 remains the same, right? Those pixels values remain the same and others become white, right? So we can use this method here, see? So all the pixels, not this one, so all the pixels less than 120 remains the same. So the coins remains its original values, original gray values, right? And the background becomes white, see? So now the coins are not black here. The coins remains at its original gray values, right? So what we have done here is that we filtered out the background and we have extracted the coins, right? Got it? So all the pixel values less than 120 remain as it is, and all the pixel values greater than all the pixels values less than 80 remains as it is. All the pixel values greater than 80 becomes white, right? So that's why you see the coins in its original color, right? So it's not, it haven't become like black or white. Okay, now, so can you imagine what actually happens in this threshold function inside? It's a very simple function, right? So if I can if I can define my all threshold function, this is how we are going to do it, right? What? So I have defined, now you are familiar with functions, so I have defined my own function. Now I wanted to show you how this thresholding is done. See, so you load the image and I pass it to the function that I created. So I wanted to show you how this is done actually, right? So very simple thing. So I pass the image and I pass the threshold value here. Let's say image and threshold value. So image comes here and the threshold value comes here. And from the image.shape, we take the row numbers and the column numbers, how many rows and how many columns. So we run 2 for loops, right? And we iterate to each and every pixel, right? So this row goes through rows and this line goes through rows, and from this for loop, it goes through columns, right? And so if you combine these two, this goes through each and every pixel value, right? So you know that this is like iterating through a, right? Iterating through a 2D matrix, right? Like this. First row, then the second row, third row, likewise. We go through each and every pixel, right? Then we check whether the image, that pixel value is greater than threshold, and we make it white, or else we make it black. And finally, we return the image, right? Got it? So this is how actually it's done inside the function. Understood? So very simple thing. So this is why this is called point processing or pixel-wise operation. So you compare each and every pixel and do this, right? You compare each and every pixel and do this. Got it? Understood? Right? Okay. So that's thresholding. Now, again, we will use thresholding for like application today, but for now, this is what you need to know about thresholding, right? Okay. And also, if you want to save an image, right, after doing something, if you want to save an image, let's say, okay, let me do something like this, right? Image, I'm going to read the flower image, and I make the 200, all the row 200. So the 200th column, yes, the 200th column, yellow one, right? So I make the 200 column yellow, right? then I write it. So this is how we are going to write the image into a physical file in OpenCV. You have to give the path. You have to give the path of the image where the image should be saved, and this is simply the image that you want to save, right? The image path and the image that you want to save. So if you run this one, you will see that in the working location, new flower. See, this is saved as new flower. Got it? So you can save image into physical files using this one. Got it? Understood. Right. Got it? Right. So now you know we discussed about thresholding as well as color conversion, like converting color, changing color spaces into RGB, HSV, YUV. Likewise, we discussed about several color conversion methods, right? And what now we are going to do is discuss about another color, point processing or pixel-wise operation method, the color segmentation. Right? Color segmentation, and this is very interesting topic that we are going to build up application from this one, right? And so in color segmentation, what do you mean by color segmentation? So if you want to extract or if you want to segment your image based on color, right? Or else if you want to detect some object, or if you want to extract some segment in your image, a given image using color, based on color. Okay, we want to detect blue objects, we want to detect yellow objects, we want to detect green objects, likewise. So based on the color, if you want to segment some part of your image, right? And if you want like detect an object using color, or detect an area, not object always, but area using a color, then that actually what we are going to discuss under color segmentation. So after completing this section, you will be actually what we are doing here is this kind of a thing, right? So now you can see based on the color, right? Based on the color, we detect this plant, right? So based on the color, so we look for green color, and we detect it, and finally what we can do is now that's one thing, that's detecting, but the primary objective is like detect the height of this plant, right? Do something important, right? Got it? Okay. Right. So so can you see color segmentation? So we have detected an object based on the color. So that's what you call color segmentation. Right. So let's see how color segmentation can be obtained or can be done in OpenCV quickly. Right. So in order to perform color conversion, and in order to like not perform, but in order to do color segmentation, perform color segmentation, we don't use the RGB color, right? The RGB images, right? It's a bit hard to do color segmentation with RGB images, right? Therefore, we use another color space called HSV, right? So for color extraction or color segmentation, HSV color format is better than RGB, right? HSV color format is better than RGB. So we'll see what you mean by HSV and what do you mean by RGB. And so if you load the image, right? Let me show you after loading an image, and right? So we load the image here, color 3. So that means this image, this one, right? So we load this image. Nice colors are there, right? So what we'll do, we load this image, and you can see using the convert color function, we covered this earlier, right? Using the convert color function, we convert this frame, the color of this frame, into HSV format, right? HSV format. So BGR to HSV, BGR to HSV. So what happens now? We show the frame as well as the HSV, both the frame and the HSV. Now this is the original image and this is the HSV converted image, right? So see, right? So these are the two images. Now actually, now it's bit right? So it makes no sense for us, right? It actually makes no sense for us. We can't even identify what these colors are. And it's a bit like a destructed image for us, right? A damaged image, right? Makes no sense. A negative kind of image, right? So it makes no sense for us. But the right side one, the right hand side, yeah, it's quite nice and it's quite beautiful, and we can identify colors separately. Yes, that's comparable for us, but not for the computer. And for the computer, this one is better, right? The computer, this one is better than this one, right? The computer can clearly identify colors if it is in this format, right? Understood, right? So let me, before doing anything, let me show you one thing, right? Now, this is the image that you had, and I defined two color ranges, right? I defined two color ranges. Let's see. Now, yeah. So this is a color, you can see, this is a color. So these are like not BGR in this method. These are like considered as H, S, and V values, HSV. Now, what do you mean by HSV? In HSV images, you don't have BGR components, but you have three components. Now, I told you in the first day in image processing, that means yesterday, if it is a color image, definitely there will be three components. Not necessary to be RGB, but it can be HSV, it can be YUV, likewise. So any color image, always minimum there will be three components: BGR, RGB, HSV, YUV. Likewise, we have different color formats. So what I mean by this hue, saturation, and value, H, S, and V. So in HSV color space, right? HSV color space, a color, a single pixel value represents by three components. They are H, S, and V, and they call hue, saturation, and value. So what I mean by hue, saturation, value, hue and saturation, right? So right, so hue 0, right? So hue is like a angle, right? Hue is like a angle, right? So hue is kind of the angle of this, right? It's like this. If you create a circle, right? Hue is like the angle, the hue value, right? Hue is like the angle, right? So you can see it's kind of an angle, right? So if you mark like the 0, right? So it's like 120, let's say, right? So if you mark a 0 point, let's say like 0 like this, and right. So what this hue means, hue is sorry, right? So 0 hue, right? So if the hue value is 0, that means red, right? And if it is 120, that means it's green. And if it is 240, that means it's what? 120 green and 120 blue, right? So that means if you draw I mean, I'm going to see the plan view of this one, right? I'm going to see it from the top, right? If you see it from the top, I know, not need to be seen it from the top, but you can see So it's like this now. This is where, see, okay. So this is the 0 line, let's say, right? 0 line. And from 0 to here, actually somewhere here, right? Somewhere here. That's right. So this is like 120. This part represents red, right? I mean, not always red, but some kind of a red, right? So then from this 120 from 240, right? So this is where the blue starts, and this range is blue, likewise, right? So that's what hue means. And then what saturation? Saturation controls the color, amount of color used, right? So 100% saturation means the purest color of that color, right? So here, see, so if you are here, it's like, I mean, kind of a white color, but here when it comes here to this, to the perimeter of this circle, it becomes pure and it becomes like light, right? And the value is the brightness. So you can see the value when it is here, the color is dark color, right? So when it goes up, it becomes like bright, right? So these are the simple meaning of this HSV, but RGB stands for something else. But HSV, like hue, is the kind of the pure color, right? Hue is the pure color, and saturation is the amount of color used, amount of that specific color used, and the value is simply the brightness, right? So it's 0, it's darker, and when it comes to a higher value, it's like a lighter color, right? So anyway, HSV has a different representation compared with RGB. So what I have done here, I have defined an upper color and a lower color. So this is a color. So this is color in HSV. So this is the H component, and this is the S component, and this is the V component. And again, this color also, they have 3 components, right? So what we can do, right? So we have a function called cvd.inRange, and into that I pass the HSV color format, and thereafter I give this low color and the upper color, the lower color and the upper color. Right? I simply use the lower color. I simply give here the lower color and the upper color. So what happens? It gives me a result, right? So without doing anything, let me do this and show you what happens. So this mask, whatever the mask that you are going to get here, the resultant image, right? So let me show you. Okay, so this is not import now. This is the HSV, right? So you can see that this is the mask, right? This is the mask. Right? That's the mask image. So can you guess the color that the lid highlighted here? Which color lid is it? Yes. Blue, right? So now what happens here? These 2 values that I have provided. Now these are just like some magic numbers. You don't know how these values are taken here, right? You don't know how these 2 values are taken here, but I will explain how to find these values, right? I'll explain how to find these values later. But for now, you don't know how these values are taken, but what you can see, what you can like deduct here, that we have provided 2 colors. So in this one, it has extracted some color here. So to be exact, the gray color. So all the gray color pixels are extracted here. All the gray, all the blue color, right? All the blue color pixels are extracted here. Can you see? All the blue color pixels are extracted and all the other pixels are neglected, right? So what this in-range function simply does, it takes this image, right? And each and every pixel, right? It's going to go through each and every pixel as we did in the thresholding, right? As we did in the thresholding, it goes through each and every pixel available in the image and check if that image is in between that pixel value of the image, each pixel value, it's going to go through each and every pixel value. And it's going to check whether each pixel value lies in this range, this upper and the lower color, right? Whether it lies in this range. If a pixel is in this range, what happens? That pixel becomes white. That pixel becomes white. And if a particular pixel is not there in this range, that becomes black, right? So all the pixels in this range, the lower color and the upper color range, becomes white, and all the pixels not in that range becomes black, right? So it's also kind of a thresholding method, but it's not like, okay, greater than value, greater than the thresholding value, make it white, and greater than the thresholding value, make it black. No, less than the thresholding value, make it black. No, it's not like that. But here it's checking whether it's in a range, a particular range, right? Understood? Right. So this is like we have extracted the object, right? So now don't get confused here. Don't think, okay, how you take this value, how we are going to find these two values. Is there any specific method? Yes, I will explain how to do that. So this is the lower value for blue, right? Lower value for blue. And this is the upper value for blue, right? So how to find these two values, I will explain, right? How to find these two values, I will explain that. But for now, what you need to understand is, okay, this is a good method where we can give a range, right? Where we can give a range. And in this range, if we have the pixel values in this range, the pixels where the pixel values in that range will become white, and all the pixels which has a pixel value not in that range become black here, right? So that's what happened here. That's what happens here, right? Understood? Right? Okay, good. Now, the other thing, this one, right? So I do something like this here. I perform bitwise AND operation between the frame and the mask, right? I'll perform the bitwise AND operation in between the frame and the mask, right? So that's what this function does, right? So if you perform bitwise AND operation, what happens? Bitwise AND operation. Bitwise in the sense here, pixel-wise. So we are going to perform pixel-wise AND operation here. The pixel-wise AND operation. So each corresponding pixels of the two images will be multiplied. All corresponding, each corresponding pixels of each image will be multiplied. And like multiplied in sense at AND operation, right? So what's the black, the pixel value, the black color represents, that's 0, right? And in the binary image, the white color represents 1, right? Got it? So this is a binary image. Binary image sense a black color image, right? So in black color images, the black images represents 0, white pixels represents 1, right? So what happens if you are going to multiply something from black or something from 0? What happens? Anything multiplied from 0 becomes 0, right? That means all the area, all the pixels that will be multiplied from these black pixels, right? They become black, right? And all the pixels that going to multiplied in this area, right? They are 1. So if you multiply something from 1, what happens? If you multiplied something from 1, what happens? It remains the same, right? So if you multiply 120 by 1, it's 120. If you multiply 120 by 0, it becomes 0, right? So then what happens here? Let us show that image as well, the res image, the resultant image. This one, after performing the bitwise AND operation, this is the resultant image that you are going to get. Let's see. So this makes sense, right? Why? Now, can you see? The white area remains as it is, right? All the other pixels, they have become black. They have become black. Got it? So what's the reason? Anything multiplied by 0, now this area, right, will be multiplied with 0, right? So that area becomes black, and this area multiplied with 1, right? So this area. So that's why you are going to see that area in the original color, right? So can you see now we have performed the object detection, not object detection, color segmentation, right? Or else we can say we have simply detect an object. We have simply detect an object using color segmentation, right? Got it? Understood, right? Okay. So now, okay. Now, so these are the ranges that I have found, right? So these are the like general ranges that you can use for right, detecting a specific color. For example, let me run this color. So this is the blue one. You can see the blue is detected correctly, right? And can you see now, this is perfect than this one, right? So some values are changed. So this is perfect than the earlier case, right? It's perfect than the earlier case. And if you plug these two values, now I will let you know how to find these values, but let me first apply those values and show you. Right? See, now this can extract what? It can extract green. See? And let's try with red as well. Not perfect, but detects, right? It detects red. Not perfect, but detects somehow it detects. Yeah, right, not perfect. So let us discuss how this is done simply, right? So now, right. So I will do it for the plant image, this image, right? So we want to like, I'm going to get the D14 image of the plant. So this image, I'm going to take this image, and let's say that, okay, we have a task, right? So we have a task to complete here. What's the task? Okay, somehow we want to detect the plant, right? So you know that's green, right? That's green. So how you are going to do that? How we are going to do that? Right? How we are going to do that? So now you need you can do it using this code, right? So this code is very important, right? This code is very important. I'm not going to go through all the details of this code, but finding the color range, this code can be used to find the color range, the upper and the lower value of the object that you are going to detect, right? So now what I'm going to do, I'll show you now. You know the magic, right? So you know the magic. Okay, so if we can define two values like the lower value and upper value for a specific color, we can detect objects. So we have done it, and you saw good results here, right? So you saw good results here. For example, now if you use these values, right? So we can see it's detected, right? The color is detected. Right? So you know this can be done, right? So this can be done simply. You can detect objects. So in order to do that, the only thing you need is two lower and upper values, right? So you want to define the boundary of the color that you are going to detect, right? The boundary of the color that you are going to detect. That's what you need to do, right? So you can you have to define the boundary of the color that you are going to detect, the lower value and the upper value. So I'm going to now explain how to do that, right? So if you can find this lower and upper value, you have to only substitute them here in this code, right? So if you can substitute those lower and upper values, you can find the color range simply. So that's what I'm going to do now, right? So in order to do that, you can use this code, this find in the color range code, right? So the image that we are going to use is this one now, right? So my objective is, okay, I have a project here. I have a project. So what's the objective here is to somehow detect only this plant and make all the other pixels black and detect the plant here, right? So that's the purpose. That's the task that I'm going to complete here, right? Okay. So let's see how it's done simply. Right. So this is the code, nothing to worry about this code. So what you have to change here is the image that you are looking for the color. So you have to change the path, right? You have to change the path here, right? The image that you want to decide the color range, you have to give that path here, right? Then after that, the upper value you have to provide. The upper value of the green you have to provide, right? And you can find it from the internet very easily, right? So if you, right, so this is how now, you know, again, in order to segment the image using a color, right? In order to segment the image using color, you need the lower and the upper value of that color. So if you have that color, then you can detect anything. So now the upper color, you have to get it from the internet, and we have several resources where we can find the upper color, right? For example, if you go to the internet and simply search, okay, the upper HSV value for green, right? Upper HSV value for green. let's say OpenCV, right? So then you will find, right? Let's see. Not there. Let us find now. I wanted to show you something where these values are available. Um, um, right. Right. So you can find it in the internet as well, right? Or else what you can do now, you know, the pure green color, the H value starts from 120, right? 120, the angle 120, right? The angle 120. Right, the angle 120, but we have to provide here um, yeah. So 120. So what I'll do, give me a second. Yeah. So this is where green starts, right? So the green start, this is where green starts, right? I'm not sure whether the angle needed to be provided here. Give me a second. Right. So in OpenCV, yeah. Okay. Yes. So in OpenCV that you have to provide, right? You have to provide this color, the HSV colors, and the ranges are H ranges from 0 to 180, right? H ranges from 0 to 180 in OpenCV, right? In OpenCV, H H value goes from 0 to 180, and S value also, it's going from 0 to 255, right? And V value goes from 0 to 255. right? So what you can do here now, then, right? So let me, yeah. So red starts, right? Red starts from 0. This is where red starts, right? 0 to, we can say 0 to 60, right? And then green from like 60 to 120, right? And then blue is 120 to 180, right? So this is the range. Got it? That means the H value. H and S, now you know this is the power of HSV. HSV, H defines the pure color, whether it's red, green, or blue, right? So you can see like the red. So let's say that I think this is where red starts actually, somewhere here. Let me get a better. Zero to 180. I think this gives you the thing is now this is having 0 to right. So now this is the correct one, I think, right? So if it is like, let's say, let me get it here. Right. Right. So it's like 0 here, right? So let me get it like this. And this is 0 like here. And when it comes to here, it's like, okay, 0. And it's like, yeah, this is like 60. And this is like 60 to 120. You are going to find this green range and this red range from 0 to 60. And again, 120 to somewhere here, 120 to then 180 again. You are going to find the blue range, right? So what you can do now, so you know that from 60 to 120, the green range lies, right? So what you can do now, upper range, you can give the upper range like this, see? So you know that the green range is from 60 to 120. So you have to define the upper value, right? So what I'll do, since it's upper value, if you want, let's say green, I'll like, okay, we know that it means 60 and 120, you have the green color, right? So I give some middle value, 100, and I give the maximum compound from S and V, right? So you know the green value simply lies between 60 to 120. Therefore, what I do is I simply give a middle value and I check. I can't exactly say I check, right? I give a middle value and I check, right? And H and SV, since the upper value, since this is the upper value, what I'll do, right? What I'll do is I give them the maximum value. H and S and V maximum value, right? And the lower color, what you can do when you run this, so you have to give only the upper color. Only the upper color you need to be given here, right? Then what you can do here is that you can simply chain these things. Right? And you can chain this until a proper segmentation is done. A proper segmentation is done. You can't always get the perfect segmentation, right? But you can get it like the best way, right? You can't, I mean, sometimes you can, but not always, right? So always you can't get rid of all the other pixels, but you can get the best now. Yeah, you can try your best to get only the plant detected here, right? Okay, I think I can't go beyond this. I can't go beyond this, right? Got it? So then fine. Okay, H, S, and V, right? H, S, and V. So now these H, S, and V values, you have to now 29, 54, 121. 29, right? 29, 54, 129. So now these will be the lower values. Got it? Huh? Right? Right? So then you can escape it. Now, this is green, right? So shall we try it for red as well? Right? Red as well. Now you know the red lies between what? Huh? You know that the yeah. So you know that the red value lies between 0, 60, right? 0, 60. So let me check whether there is any kind of a image with red. We have the flower image, right? But not the flower image. We will use this one. Yeah, I think it's better this one. Is it? Yeah. Colors JPG. Let's use this colors JPG and check whether can be done. Okay. So my objective is now to detect red, right? So the upper value, you know, upper value is like lies between what? It lies between red value lies between 0. Now my objective is to detect red. So 0, 60. So let me provide the value between 0 and 60. Okay, I think we will give like 20. We will check. I mean, you have to anyway provide the value between 0 and I think not 60, but something less than 60, like 40, let's say. 40, let's say, right? Other values I give the maximum. H and S I give the maximum, right? So you know that the H range for red is between 0 to 60, right? So I give a higher value, but not the maximum, right? So something less than maximum, like 40. I'll check it, like, right? So if you run this one, okay, you have something like this now, right? Okay, good. Let's see whether we can do this. No. Yeah, no, right? The yellow is also detected, right? The yellow is also detected, right? So let me now, so yellow is detected. Why yellow is detected? Let's see. You can see, right? So you know, okay, this is 0, and we know that this is something where like 60, right? So the range, the upper value that we have given is bit high, isn't it? Huh? It detects yellow as well, right? So what you can do now, you can change this value a bit. See, let's say like 20 and see what happens. Perfect, right? See, got it, right? So very interesting, right? Now the thing is, you have to always keep and track about the HSV values, right? HSV values. Now, if you want to detect a reddish color, 0 to 60, green 60 to 120, blue to 1 to 18, right? So now, what about yellow color? See the yellow color, right? So this is the yellow color. So you know what? You know, actually this is where, right? I think this is where the red lies. This is where red lies, this range, right? So if it is 0, this is 60, let's say. So red lies in between, right? Red lies in between these two, and green lies, I think, in between these, right? This is the green range, and this is the blue range, I think, right? So in order to, if you want to detect yellow, I think very closer value to 60 should be given, isn't it? You have to provide a very close value to 60. Since the yellow is the higher, in the very top of the red range, right? So shall we give like a value around 50 here? You know the maximum value of red is 60. So I'll give something like 50. Let's see now whether we can detect yellow. Perfect, right? Some issues are there. Yeah, fine. Got it, right? So you can detect any color here. So this is the lower value for H. H8, 67, 145, right? So this is the lower value for yellow, right? So what is important here is this figure, right? This figure is too large. Shall we? Not this one, but here, this gives you a very good understanding. This is fine. See, right? So this is 0. This is something 0, and this is where like 60, and this is where you are going to like find 120, right? So this is the red range, and this is the green range, and this is the blue range, right? Got it. So you have to provide the high value based on this one. H and S you have to provide. You can provide 255 always. So the H you have to select, right? H can be selected from this one. Got it? Right. So you can detect any color now. Understood? What you had provide. Keep this in your mind. This finding the color range is the code that you are going to do that, right? And H value, this, in order to detect a color, perform color segmentation, you need the upper value and the lower value. You can find the lower value, but you have to define the upper value. How to define the upper value? You have to select the H value, h and s, sorry, s and v value, you always you have to provide the upper value. In upper value, you have to provide it like 255, right? How to define the h value for the upper value? You have to define, okay, red between 0 to 60, green between 60 to 120, blue between 120 to 180. Then what you'll do, according to this graph, you can define it, right? So if you want to detect yellow, okay, you know that this is the range, right? So you then give a, okay, you can see that this is something 60, right? So I give upper like upper value like 50 or 60 also even fine, right? Then you can select the lower value by changing the sliders, right? Changing the sliders of this one, this code. Right? So that's how we are going to do the color segmentation simply, right? So now what I have done here, I have found the green upper and the lower values. I can't provide, yeah, I put 0 here, 100 here. So this is the lower values I found for the green. Now what you can do is simply you can now detect the, see, now this is the result that after doing the bitwise AND operation. This is the mask, see, perfect, right? Not perfect, but somewhat okay. Now we will get rid of these small yellow, I mean green color things here. Understood? But this is fine for now, right? So we can get rid of these things, right? So this is a very good method of detecting objects, but one condition given, right? You can't have any other object in the same color here, right? You can't have any other object in the same color here, right? So if there is a green color ball here, that also would be detected, right? But there are methods to overcome these things. Now here also you can see some tiny little kind of parts of leaves and everything is there. So those colors are similar to this green color. So they are also detected here, right? So they are also detected.
I have a question.
Yes.
Now you said that if you have a similar, if you have an object with similar color, and it's very difficult to detect the plant. So if we slice the image, if we know the coordinates, like the pixel values where the image is located, if we slice it, then can we just detect that part?
Yes, exactly. A good method. But unfortunately, like if you are doing it for a video, what happens? Right? If you are doing for a moving object, that cannot be done. Yes, a good suggestion for a still, I mean, this kind of, now, let's say this kind of a thing. Now we are in a kind of, let's say a greenhouse, right? In a greenhouse, you have attached a camera and you are not visiting inside and you are not manually measuring the height of it, but now this is actually a similar project, right? This is a project where like from day 5, you have to measure the height of this plant, right? So that was the objective of this project, right? Got it? So anyway, now we want to automate this, right? For this kind of a purpose, what you mention is quite fine. If the object is still, right? If the object is still, that could be fine. Since you can crop the other parts, you can crop the other parts and take this, right? But unfortunately, if you are doing it for a video, a moving object, it cannot be done. So we have other options, right? Other options like we can get the area of these detected objects. Get the area, right? So if you get the area, simply you can, like if the area is less than a particular value, you can neglect those detected objects, right?
Like when you say area, you mean pixel?
Yes, pixel. I mean the pixel.
So all the green pixel area combined together.
Not combined together. What we can do is now in the next topic, right? In the next topic, what we are going to discuss is we are going to discuss about contours. So we can detect these closed areas. So these are closed areas, right? So we can detect these closed areas and we can get the individual area of each those contour, right? So then after that, comparing the area, we can neglect the smaller ones, right?
Okay.
Or else we can get like Okay, so let's say that there is a very large green object in this one. You can get the range where a kind of what the plant lies. Okay, between 2000 to 2000. So any smaller or any larger object will be neglected, right? I will discuss about this, right, in detail. Now,
Thanks.
one part is done. So now we have segmented the image. Now, this is something that anyone can do, right? So you have to just follow the color ranges, right? So you have to just follow the color ranges, and if you extract the colors, and this is something that you can do. Very simple, right? But if you want to measure the height, we have to move and we have to do some advanced things from here onwards. Right? This detecting is fine, right? Now, face detection, let's say, you will find like 100 codes, right? In like where you can just copy and paste, and you can run in your Python code, face detection. Similar thing, right? I mean, a very straightforward thing. Very straightforward thing. So, but I mean, yeah, let me show you something. This project won't be covered in your course, right? But I will tell you one important thing here. Yeah. Right. Now, detecting object is something that we can do with few steps, few lines of code. But implementing something like this, I mean, something like this. Now, this is something, right? See, detecting object and doing something from that. See, so here we count the number of vehicles here, right? Number of bikes pass this line, a bike counter, a vehicle counter, right? So detecting object, now you will see like 100 projects done in face detection or vehicle detection, but this is something useful, right? Isn't it? In this one, we try to do something from that detection. So similar thing we are going to do here as well. Now, nothing happens if you detect a plant, right? So if you detect this plant, yes, it's something, right? Okay, you have detected the plant. Okay, but what's the use? No use, right? No real use. So if you can, okay, now if you can detect the height of this one, okay, then that's a very useful thing to do, right? So now we are going to discuss how it's done, right? How it is done. So now, yeah. Yeah. So now let me start a new code and I'll show you, right? So up to this point, you are good, right? So up to this point. Right? So this is the code that we have done earlier. Right? This is the code that we have done earlier. We detect the plant, right? So we load the image of the plant, and here a reshaping is done. Sorry, resizing is done. Not necessary, but what this resizing means. Now image.shape simple gives you height, width, and 3, right? For a color image, height, width, and 3. So we take frame.shape, height, width, and shape, right? So you can remember, right? So if you print the frame.shape, it gives you the resolution like height, width, and the 3 simply stand for like 3 components BGR. So then what you can do is you can use this resize function. Resize function in OpenCV simply resize the image, right? So here what I am trying to do, the frame, the captured image, I resize it to, so it's like this now. This here you have to provide the height and width. Sorry, not like this, but you have to provide the height and width and height here, right? So the resize function, we can pass the image and then we can pass the new size you want, the height and width and height. The new width and height you can provide. So it resize it to that size. For example, now if you provide 100 here, right? So now if you show it, so you can see 100 and 100 image, right? 100 and 100 image. So this simply, which one? Yeah, this simply resize the image. But if you convert it to 100, what happens? The original shape will be missed, right? The original shape will be missed, right? Therefore, what we do is, I think you can understand, right? So let's say we have a 1000 by 500 image, right? 1000 and 500 image. So if you make it like 100, so the shape, the shape will be like the original shape will be removed, right? Therefore, we have to do it like this. What we do is we give the width, we convert it by a, we scale it, right? Let's say divide it by 2, both height and width, you can divide it by 2 or 4 or 5, any equal scale, right? Now, this is half of the original size, right? Half of the original size. Got it? So resize command, another function available in OpenCV. So my point here, in this one, what we have done, so this is something that you are familiar, right? Getting an image, right? And resizing it, I just discussed, and converting it to HSV. Why HSV? Now we are going to detect color, right? So we are going to segment using color. So color segmentation is a bit hard with BGR. So the most efficient way of doing color segmentation is using HSV. So what we do is we convert the BGR image to HSV and we take the HSV, and this range is the range that we have already defined, right? So can you remember the range that we have already defined there, right? The low and the upper values, the low and the upper values that we have defined. So in the in range function, you can remember, we input the HSV and we provide the low and the upper color. So this simply what? This simply detects, it makes all the pixels in this range to white, and it makes all the pixels not in that range to black, right? So that's what you are going to get here. See? Okay. So with this one, what now we are going to do? Now, the only issue is that somehow we want to detect the height of this plant. So that's the primary objective of this thing, right? So this is something anyone can do. Defining the color ranges, it will done everything, right? But we have like go a step further, and we have to measure the height. So there's a small barrier to that thing. We have detected some unwanted objects here as well, right? Unwanted objects, right? So anyway, before talking about the unwanted objects, we need to discuss about one important thing here. Now, next thing, now we have detected the plant using the color. Then I'm going to find the contours available in this mask. I'm going to pass this mask to a function called cv2.findContours, right? cv.findContours. I'm going to pass this mask. So this mask, you can remember a black and white image where the yellow, the green pixels are highlighted in white and all the other pixels are black, right? So I pass this mask here, and the function is findContours, a very powerful function in OpenCV. And we have two things to pass here called the retrieval method. So this is the retrieval method, and this is the approximation method. Two things retrieval method and the approximation method. Don't worry about that. I will provide you some sources to get to know about this retrieval method and the approximation method. Actually, is it going to work without this? I'm not sure. Let's see. Yeah, you have to provide this. Yeah. Anyway, so this is called the retrieval method, and this is known as the approximation method. I will explain about those things later. And this returns two things. This find contours function returns two things: the contours and the hierarchy. Contours and the hierarchy, right? The hierarchy actually gives you, I will discuss about the hierarchy later as well. So hierarchy, retrieval method, and the approximation method. These parameters I will discuss later. But now we will focus about only this. Okay, we pass the mask, the black and white, the binary image into this find contours function, and it returns us the contour. Don't worry about these three. We will discuss about these three later. Right? So what I mean by this contours? This contours is the contours. This contours array. This is an array. This contours has all the closed areas of this masked image. All the closed areas, right? So if you print the length of this one, length of contour. So this is an array as I mentioned, right? So it gives you something around 28. So it has detected 28 contours here. So what the find contours function does, it finds the closed areas. If your image is black, it finds the white color areas, white color closed areas. That's what it does. So it has found 28 closed areas, white color areas in this image, right? So shall we see what are those areas, right? So in order to do that, you have a function called draw contours, right? This function. So let me show you that one. I have detected the contours and I draw those contours, right? So what this draw contours means, okay, draw all the contours that you have detected in the frame. Frame in the color image, the original image. So we show the contours in this frame, right? And this is all the contours that we have found. So we pass the contours and we draw those contours in this frame. So frame is the original image, right? The original color image. So in the original color image, we draw all the contours that we have detected, right? And -1 simply says draw all the contours, right? -1 simply says draw all the contours. And this is the color that you are going to draw the contours, right? The color of the contours that you are going to draw. So this is green color, right? I think it's better if we can use some other color since the plant is also in green. So you use the yellow color, and this is the line thickness. The line thickness of the contour line detect. So you will see what I'm trying to say here, right? I think it's better if we can use red color. You can't see it clearly. I used the red color earlier, sorry. Right. So let me increase the line thickness a bit. Now can you see the contours, right? Right. So there are lots of contours, right? Not only our plant, but we have some other contours as well, right? So this is what the draw contours function did, right? So -1 stands for like draw all the contours, and this is the color of the outline of that contour, I mean the drawn contour, and this is the line thickness of the contour that we have drawn, right? The line thickness, see, right? So now -1 simply says to draw all the contours, but you can pass a single value. Now you know that we have 28 contours. shall we see the first contour? 0. If you provide 0, that means it's going to draw the first contour. Can you see here? So this is the first contour, this one, right? So second contour, shall we print the second, show the second contour? Right. And the third contour? Yeah, let's print the 26th contour. 26th. This one, something in the leaf, right? And 10th contour. So we have 28 contours, right? So we can't actually find where the plant here, right? So which contour actually represents the plant. We can't find it. But anyway, yeah. Unfortunately, we can't find it. Let's say 20. So my point is, plant is somewhere in this 28 contours, right? Plant is somewhere in this 28 contours, right? So we have 28 contours. Let me show you one contour. So I'm going to print contours. Contours, let's say something like 4. And I will draw the contour 4 as well. Okay, so this is the contour 4, right? That's not a good contour to show you. Like we'll take another contour, like 6. Eight contour. Anyway, let me try once. 12 contour. Let's see. Anyway, it's not coming, right? Anyway, now when you print the 12th contour, right? So when you print 12 contour, this is what you are going to find, right? So what this point represents actually, right? So you have some contour like this here, right? So what this values represents, now contour is represented by what? It represents by some set of pixels, right? So let's say that you have a contour like this, right? And what these points represent, now here, I think here four points, but the number of points changes, right? Number of points changes. So anyway, it gives you the boundary, the critical boundary points of this, critical boundary points of the contour, right? So the boundary points changes with the number of boundary points changes with the size of the contour, right? So anyway, right? So if you take this point, right? So it gives you the x value of this point and the y value of this point. So that's what gives here. Right? And this point like x2 and the y2, right? Now don't think, okay, right? The thing here, now don't think, now here how many points? 4 points are there, right? Don't think all the contours are containing 4 points. No, it's not, right? It's not. Now the tree might have like 1,000 points, right? So it's depending on the shape and the size, right? The number of bounding points. Okay, here we have 28 contours. So what do you mean by contours? Contours is closed area. So if you, now here I have printed the 12th contour. I want to see what is there inside the 12th contour. So 12th contour, there are four points, right? 4 points means that this is the 12th contour. I think you can see it right here. The 12th contour is here, right? So these are the bounding point of those. I mean, of the 12th contour. There are 4 bounding points. Don't think that always there are 4 bounding points. No, it differs with the shape and the size of the contour, right? So anyway, what do you mean by a contour? Contour actually has the bounding points of the each contour. Understood? What exactly does retrieval and chain approximation means, right? So this is the retrieval method and this is the approximation method. Actually, it takes lots of time. I will OpenCV contours Python. Yeah. Yeah. So you can actually now the contour approximation method, right? So you can actually read it from here. I will share with all of you, right? And the other thing, yeah. So contours. Can you please give me a second? Right. Contour properties, contour hierarchy, right? So the hierarchy is actually about the it gives you an idea about the retrieval method and hierarchy is the same thing. So retrieval method, we have several retrieval method: tree, external, see, compare, retrieval tree, right? So we have lots of retrieval methods. Now retrieval method simply explains you idea about if you have a contour inside another contour. For example, so here now 0, 1, 2, and inside the second contour, we have some other contours. So they become like parent and child relationship, right? So they considered as a parent and child relationship. So there is a big theory behind this, right? So anyway, I'm not going to take time here to explain this specific topic, the retrieval method and the what mean by the approximation method. But approximation is bit simple, right? Approximation method is like, okay, so if you have right, so let's say now if you have this kind of a shape, right? If you have this kind of a shape, if you like retrieval method, if you don't use a retrieval method, it detects all these points like this, all these points. But if you use a retrieval method of simple retrieval method, right? A very simple retrieval method, it's not going to detect all the boundary points, but critical points like this, right? It's going to approximate. That's the contour approximation method. So we are using that method here. See, we use the approximation simple method, right? For example, I will show you now. In the same, like the 12th contour, we have only 4 points, right? So that means it like neglected the redundant points. The similar points neglected and only critical points are taken. But if you make it approximation none, so now this will take lots of points. Let me show you. Yeah, for this one, I think it's a very simple shape. That's why, I don't know. Can you see it's taking 5 here, right? Earlier it was 4, right? isn't it? Yeah, it's 4, right? So if you like make it none, no, only not, sometimes like 10 points might be 100 points, right? But here, like, can you see now these redundant points, some of the redundant points are neglected. That's what it does simply. If you use simple, right? So that's the approximation method. And the hierarchy is about the parent and child relationship. Something, if there's something inside another contour, a contour inside another contour, how to handle this, right? So that's what the hierarchy means. And the retrieval and the hierarchy, that's what they mean. So you can have a look, or you can read them, but for this application, no need to worry about this. These are, I mean, most of the applications works with these two, but any special case, sometimes you may have to change these things, right? Anyway, now you know a contour is simply set of points, right? So the thing here that, again, let me show you all the points, right? All the points. So we have some unwanted points here, right? See, some unwanted points here. So we don't need those unwanted points. We need only this one, right? We need only this, the tree, right? So what we can do, as I mentioned, we can filter the unwanted contours by simply getting the area of each contour. So for contour in contours, I'm going to go through each and every contour in my right, each and every contour in my thing, right? For contour in contours. Then what I'm going to do, I'm going to get the area. So there's a function to get the area of a contour, cv.contour area. So I go through each and every contour and I get the area of that contour. That's what I do, right? So, and I print the area, right? See. So these are the areas of each and every, I mean the 28 contours, right? The 28 contours, these are the areas. So some of the points are like neglected. Why? Very small. That's why the pixel size is not given, right? They are very small. That's why you are going to see 0, right? Now, can you guess where the contour is? Our contour is the area. Can you guess the area of the contour? Which one? Now, this is the areas of those 28 contours. So can you identify where our tree is? The contour
is it between 1,000 and 5,000?
Yes, this one exactly, right? So I think if you count it, no need to count. Can you remember the enumerate? Now I told you in the first day, sometimes you found like a bit of boring since I'm just covering the theory and theory. So this is where you can use the things that we have learned, right? So enumerate gives both the value as well as the index, right? So let's see the index. 17, right? So now, shall we now plot 17 and see? Right, see? No any other contours, right? Only this contour. That's the 17th contour. Understood, right? Got it? Okay, so now we have like neglected all the other points, right? Now what we are going to do, very simple thing, right? Now no need to draw all the contours, right? All the contours, no need to do it, right? What you are going to do, if you want, you can draw the contour like the contour, we can now simply what? We can filter the contour. If area is less than, let's say, something around like, I mean, we are safe with even 1,000, right? Right. So other contours are not even close, right? So we can use a value like 1,000, right? Okay. So then what I'm going to do now, this is the condition that we are going to use to filter out all the other contours and get our tree, I mean, our plant, right? So now I draw the contour in that case, and also one important thing. Then we can get,
Excuse me.
yes.
So what is that 2 represent here, sir?
This one.
Yes.
Yeah, this one represents actually the size of the line of the contour that you are going to.
Okay. The thickness of the line.
Yes, yes, exactly, thickness of the line. Now, why this is not? Sorry. Right, so if you like put a value like 10, so this thickness is given in pixels, right? So the line is drawn here like thickness has a thickness of 10 pixels, right? So we need like 2, let's say, right? So if you put -1, that means draw all the contours, or else you can give just a number, 1, 2, 3, 4, 5, likewise, right? Got it. So then the remaining thing is, okay, to we can get a bounding rectangle. There's a function to get the bounding rectangle of a contour. What do you mean by bounding rectangle? So I'm going to pass this contour, and I'm like, what do you mean by bounding rectangle, right? So if you, let's say that if you have this kind of a contour, what I mean by bounding rectangle is a rectangle that bounds this the bounding rectangle, right? So this gives you 4 parameters. This point, right? These points x and y, the left side upper corner x and y, and w and h, right? So that's what given here, right? So now we filter all the other contours and we select only the contour that we are interested on, the plant. And from that plant, we get the bounding rectangle, we pass the contour and we get the bounding rectangle. What do you mean by bounding rectangle? It draws a, it actually does not go, I mean, it's not going to draw a rectangle, but it gives you x, y, w, h of a bounding rectangle, right? Got it? So what I mean by x and x, y, w, h, these parameters. So if you print x, y, and w, h, so you can see, so these are the x, y, w, and h, right? And the other thing, now you can see that no any rectangle is drawn yet, right? No any rectangle is drawn yet, you can see, right? So we have to draw manually. We have to draw a rectangle manually here, right? How we are going to do it? There's a function in OpenCV, right? There's a function in OpenCV in order to draw a rectangle, cv.rectangle, right? cv.rectangle. And this takes few parameters. This takes few parameters like where you want to draw the rectangle. So I'm going to draw it in the frame. And then you have to provide 2 points like now in order to draw a rectangle in OpenCV, these are the parameters that you need to provide. Now these two are 2 different things, right? If you want to draw a rectangle in OpenCV, you have to provide these 2 points. X1, Y1, this point, P1, and this point, X2, y2, right? So let me show you some value like, okay, 10, 10 and 100, 100, right? 10, 10 and 100. I'm just like drawing a rectangle, right? Then you have to provide the color B, G, R. So I'm going to draw it in red here, BGR, sorry, yellow, yellow, and the line thickness again, line thickness. So I will provide a line thickness of 3, let's say. Now, if you draw it, you will see this kind of a rectangle. See, yellow color rectangle. So what are the points here? Huh? So what it means? 10, sorry, 10, 10, and this point 100, 100. So these 2 points should be given, right? XY, X1, Y1, X2, Y2 of point 1 and point 2. What mean by point 1? This is the point 1 and this is the point 2. Right, okay. Now, can someone tell me quickly, I think you have seen it as well. If you want to draw the bounding rectangle of given by XYWH, what are the parameters that you need to provide here? Okay, so how you can define this point? In terms of XYWH. Yes. Okay, the point 1 and point 2. So I'm going to draw the rectangle around this. Tell me quickly. Point 1, yes. Point 1, quickly, quickly, quickly. Point 1, yes. I want to draw the rectangle of this bounding rectangle, yes. So you have now XYWH, yes. So the point 1 is what? Huh? Yes. Point 1 should be given here and point 2 should be given here. Yes, point 1, yes. Yes. Now, this XYWH just gives those parameters. It's not going to draw a rectangle, right? So we have to draw it manually. So my question, okay, how to get XYWH and draw the rectangle around it? Yes.
X comma Y.
Okay.
H comma W.
Sorry.
H comma W.
XY and
W comma H. Yeah, sir.
Not actually. One thing is correct, but the first point is correct, right? Now, this point you can see.
W plus, I mean X plus W.
Yeah, yeah, exactly, exactly. Right? So this point is like X plus W, right? From X, you have to add W. Here also, Y, you have to add H. Okay, done. This is perfect, right? Now, the thing is, if you haven't done this, I mean, if you haven't done this, what will now happen? See, bounding boxes will be drawn everywhere, right? Bounding boxes will be drawn everywhere. So first we have like get rid of unwanted points, right? one method is consider the area, right? So any idea what's the height of this plant in pixels? Height of the plant in pixels is given by what? Yes. Height of the plant, then how to determine the height of the plant? Yes. Height of the plant is given by what? Right, so isn't this the height? The plant, right? So plant is there, so this is the height, right? But height in pixels, right? Height in pixels. So height is given by the h parameter, right? So what we do is we put the right. So you can put the text here, right? So when you are going to put the text, what you have to do is you have to provide the text height plus the strh. That means I'm going to add the h by converting it to a string, and that will be height plus like let's say height is 20. Then this is where the text will be placed, and this is the font that you are going to use, and this is the font scale, and this is the font color, and this is the font thickness, right? So you can see something like this. We will put it here. Right, so if I explain you this, in put text, you have to provide several parameters, cv2.put text. First, the image where you are going to place the text, right? Then the text, right? So my text is height plus height converted to a string, like 300, right? So it will be height plus height string plus I have converted the number into a string and I show it like height 300, right? Then the XYWH, what do you mean by XYWH? When you have an image, let's say, okay, if you want to put a text here, right? Like let's say height, right? So this point, this point, right? So this is what you provide like XY, this one, right? So I place it at the bottom, right? X plus W, Y plus H, the point 2, right? So, right. So at the, I mean, if the plant is detected like this, I put it here, right? And this is the font shape, sorry, the font, right? The font that we are going to use. So there are several fonts available in OpenCV. OpenCV fonts. Here, font Hershey simplex, font plain, font Hershey duplex, complex, triplex, complex false, script simple, likewise, right? So we have several fonts available in OpenCV. So I use one of them here, the font type, and this is the font scale. What I mean by the font scale is the, like, one is the default size. One is the default size. And here you can't provide like 12, 14, 16. It's not the font size. This is the font scale. What I mean by font scale, if you put 1, that's the default size. If you put 0.5, that's half of it, right? if you put like 1.5, that's mean 1.5 larger than 1 point times larger than the default size. So it's, you have to give it like a scale, right? 1 is the default size. Then this is the font color. So I use the white color, and this is the font thickness in pixels. Font thickness. Font scale and thickness are two different things. Right? So height is equal through 360. Understood? And if you put 2, that means twice of the earlier size. Right? Ready? So that's how we are going to provide the font. Right? Understood? Okay, so any idea how to, now this height is coming in pixels, right? So any idea how to convert this into millimeters or centimeters? Any idea?
Do we need to have a scale, like a standard
Yes,
scale?
exactly, exactly. Yes, very good. Now the thing is, we have to make some assumptions, right? So in order to convert this into, millimeters, you have to assume that the camera and the length from the camera to the plant is fixed, right? So if it is changing, you can't do that, right? Anyway, like you can get this kind of a very simple equation.
No, but then if we have a standard scale set, and if we know the pixel values, pixel size, don't you think it doesn't matter the camera distance?
Sorry?
No, because let's say if I use a normal scale and take a picture of that using the same camera which we use to take the picture of the length of the plant, right? Now, if I measure 1 centimeter on that scale and I know how many pixels are there on the sensor in that 1 centimeter, and if I scale everything accordingly, it should be same, right?
No, it won't work, right? No, the thing is, when the distance, like this is the equation, right? Now I think you are familiar with this, right? So let's say there's a camera. In the camera, you have a lens. In any camera, there is a lens. So I think you are familiar with this thing, right? So you are going to get, I mean, this is corrected, this this will be flipped here anyway, right? So you know that this is the, okay, let's say now this is where your camera, I mean, this is where your camera, this is a lens, right? This is the lens. This is the lens of the camera, and this is the camera sensor. Right? So this is the distance, actual distance, and this is the focal length, right? And if you take this height, the actual height has capital H, and this height, the height of the image in the, the height of the object in the image, let's say, right? So the image, the height in pixels, let's say H, simple H, right? So this is the actual relationship that they are. As I can remember, I'm not sure whether I'm correct or not, but if I'm not correct, please correct me if you are familiar with this thing, right? Right. So this relationship is there, but what happens this, so what do you mean is, okay, I'm going to get this portion, right? You are going to get this, right? The actual and the predicted, sorry, actual and the image, and you are going to get a kind of what you call a factor, right? You are going to get a number, a ratio, right? A ratio, right? So what happens if you get this ratio? What you can do is simply, let's say this ratio is R, right? So then you have the pixel value right? So when you have the pixel value, let's say simple h dash, you can multiply it with the r and you can get the actual height. Yes, this is okay. This could be done, right? But right, so this will work only for this focal length and this distance, right? So if the distance change, you have to again calculate this scale. I mean this ratio, right? So there's an option. There's an option. You can use stereo vision, right? So you can use something called stereo vision, but stereo vision is a bit advanced technique where you can have two cameras, right? As like our two eyes, right? You can have two cameras and you can measure the distance using two cameras and get the real height, width, and everything, and also you can get the depth. So that method is called stereo vision. Now this is something advanced. We are not going to discuss about this. In stereo vision, you have two cameras, and both cameras you are going to capture the same image, and you can calculate the distance, and you can calculate the height, width, and everything, right? So if the the distance change from the camera to the object, it's not going to be a matter. But in this one, if you are using a camera, I mean, if you use this kind of a thing, and if you want to convert it to real pixel, I mean real distance or the height, it will work only with a fixed distance. Again, if you want to do this, you have to calculate the ratio again, right? So what you can do, as I mentioned, you can calculate the real height, right, of a non plant. If the distance is fixed from the camera to the plant, you can calculate like this, right? So this is the actual, and this is what in the pixels, right? What you are going to see in pixel, the pixel size, right? So you are going to calculate the ratio, and what you have to do is, in order to get, like, let's say you have a new value given in pixels, you can calculate it from the r and you can get the real height. But in order to do that, the distance should be fixed. Understood? Right? So that's how we are going to do that, right? But anyway, this is working well. And let us try this with, shall we try this with another image, like image number D30, this D12. So this is working for D14. Let's try with D12, right? Working fine, right? Works perfect. I'm not sure whether it's going to work for everyone, but anyway, let's apply D8. Now, there's a small issue, right? Why? The bottom part is not detected. That color is like, the range we have detected is bit you have to adjust the color range, right? So you have to now run these things and adjust the color ranges, right? That's something that you have to do, right? You have to adjust the color ranges. Otherwise, you have to select a color range which detects all the plant, right? So that's one thing, one important thing. What we had just do at these images and change those color ranges and get a better range, right? Understood. So then I have a video, right? So video, like this video. So it's like moving. So in this one, shall we try to detect the plants and the heights, right? So the same code, no difference, right? The same code, no difference. The only thing, we have loaded the video capture and we run it in a loop. Right? We run in a loop. That's all we have done. See, working not perfect, but working fine, right? Right. So the thing that we have done here, right? We have only the only thing that we have included, like we have the video source, so we'll read the video, continuously and do the same process, right? That's all. Got it? Okay, so I think you understood, so you can revisit it. And now the objective is to do this for your own application, right? So the plant height detection is something that I have done now. So it's the objective is to do it for your application, right? Okay, so then we have another section like neighborhood operations, kernels, and filters. So in this one, the same kind of a concept. And after doing this, you will be able to do a similar example like this, lane detection, right? So based on the same kind of a concept, right? Detecting lanes, not perfect, but somehow it detects lanes, you can see. Right? So anyway, this will be your example too. This will be your take home tutorial, right? Take home tutorial. That means I'm not going to discuss it in the class, but I'll provide you the video, right? I will provide you the video as I did for the last tutorial, right? And you can go through this and learn from the video, the tutorial video, how to obtain this one, right? How to obtain this one. Got it? How to do this kind of a lane detection thing. So this is kind of based on the same thing, but bit different idea. So I will provide you the tutorial for this, right? So you can go through that and do it your own, right? So it's your take home tutorial. I will provide you the tutorial of this one, right? Okay, so that's all we are going to discuss under image processing, but this is kind of a very small start, right? Kind of like we have done all the basics. So this is a very good, I mean, the fundamental knowledge we have now, what's OpenCV and what's image processing, how we can do things in OpenCV, right? Now, the thing that we have done today, we don't use any machine learning or any AI concept, right? But without using any AI concept like object detection, anything, machine learning or anything, artificial intelligence, without anything, we have detected the plant height and we have done these things, right? So image processing, you can do lots of things, right? Image processing is a very powerful section where you are going to find lots of things. So I think this is a very good start for you. So you can start your own projects and work on these things, right? So my objective is like, okay, the concept that we have learned in the class, so you have to apply it to your own application, right? So search it in the internet, right? And get some projects and see how this is done. Or if you want to detect something in your house, you can do it, right? Get the color range and everything, right? Got it. Okay, so anything now, don't think that this is the image processing. No, we have lots of other processes in image processing, right? Lots of other functions and concepts available in image processing. What we have done is a kind of introduction, right? So this is a very good introduction where you can start your own work, right? So that's my objective. Anyway, so before going on to the next section, so we have around like 30 minutes. We have like 30 minutes, so I will start the machine learning, the introduction to machine learning section. But before going on to that, if you have any question, you can ask them now and we can clarify any issues if you have any. Yes. Okay. Right. Right. So now then we will, since you don't have any questions, let me quickly start the machine learning section. So I will cover most of it, I mean some part of it, and tomorrow we can continue the rest, right? And also do the content that we can we have to cover tomorrow, right? Okay, so machine learning is one of the very interesting and very trending topic in the current days, right? I mean, in the present, so machine learning is like a very hot topic and a very trending topic, and lots of applications are done, and everyone is talking about machine learning. So there are lots of job opportunities. There are lots of freelancing opportunities, right? And you have lots of opportunities available if you learn machine learning, right? So there are highly paid employment opportunities and freelancing opportunities, right? So there are lots of benefits available if you can learn and if you can master machine learning, right? Understood? So very important topic and a very useful topic in your future. So if you can learn machine learning and if you can implement your own projects in machine learning and if you can gain knowledge in machine learning, that will be really benefited in your future, right? So we are going to discuss about machine learning, and we will be doing some practicals and get the basic knowledge on machine learning, right? So we will use the scikit-learn library for these implementations, right? Scikit-learn library, and for OpenCV we use for image-based image processing applications, and we use Numpy and Matplotlib. So today onwards, we are going to move on to scikit-learn and implement machine learning algorithms using scikit-learn, right? Okay, so machine learning, before going on to machine learning, we have to discuss about what is AI, since machine learning is a part of AI, right? So we will now quickly get to know about the concepts, machine learning, deep learning, and AI. So what are the differences, what are the similarities, and what is the relationship between each topic, right? We will discuss first about AI, artificial intelligence, right? Artificial intelligence. So very hot topic these days, again, another one, AI. So self-driving cars are there, right? And object detection API is there, right? Google Translator, right? Likewise, we have lots of applications using AI in this, real world, right? There are robots, there are self-driving cars, everything. So those are applications of artificial intelligence, right? In order to understand the concept artificial intelligence, first we have to understand what is intelligence, right? Intelligence. So intelligence, simply we say, okay, humans, us, that we are the most intelligent being in this planet, right? So we say it, right? So then using our intelligence, right? What we do? Any idea? What are things that we are doing using our intelligence? Yes? What are the things? Any idea from your side? Right? For what applications, for what purposes we use intelligence for? Any idea? Anything you do in your day-to-day life using your intelligence, not artificial, but I'm asking your intelligence, human intelligence. Yes? Anything, any example can you provide me? Something that you do in your day-to-day life using your intelligence. You don't nothing. You don't do nothing. So you don't do anything. Huh? Don't you do anything? Everything that we do, right? We use intelligence, right? So the ability of speaking, so I can speak several languages, right? That ability, yes, I do it using my intelligence. The ability to drive vehicles, something I'm going to do with my intelligence, right? And the ability of identifying objects, so we have lots of objects around me, so I can identify each of them, right? Now if you see something that you don't know what is this, so you can learn and you can identify it when you see it again, right? So if you, let's say that if you are going to see some animal you haven't see, I mean you haven't see earlier, right? So you can like you get used to that, and from next day onwards you will understand that object, right? So ability of translating one language into another language, so if you want to translate Tamil into English, you can do that, right? So you can translate something from one language to another language, right? You can do mathematical calculations. You can do logical thinking, right? You can speak, you can write, right? Everything we do in our day-to-day life, we use intelligence. Okay, another question. So did you have these capabilities when you were born? When you were born, did you have these capabilities like, okay, the like understanding and speaking several languages and driving cars and identifying colors, identifying like objects, right? You didn't, right? So that means you trained, right? You trained to speak, you trained to identify objects, you trained to identify colors, you trained to walk, right? So your intelligence is trainable, right? Shall I give you an example? So fortunately, like you are going to get a scholarship, right? And that scholarship will be like full funded scholarship, but you have to go to France, right? You have to go to France and you are going to get a scholarship for your MSc or your PhD or your bachelor's degree. You are going to get a scholarship full funded with all the facilities, right? And all the expenses are provided by the university. So you have to just go there and learn. But one condition provided, that you have to have the French knowledge, right? So you should be fluent in French, right? They provide you this condition and they give you some time. If you don't have the French speaking and the French knowledge already, so they provide you like, okay, 1 year, right? So we are going to provide you 1 year, and if you can, we are going to conduct an exam, and we are going to examine you, right? We are going to assess you, and if you can pass that exam, we can take you into the university with all the facilities, right? So a condition is given, right? So now you have zero knowledge in French. You don't know anything, even one word you don't know. Assume that kind of a condition, situation. You don't know anything about French, right? But you have a golden opportunity there, right? So your brain, okay, one task. So you have learned Hindi, you have learned Urdu, or you have learned Tamil, you have learned like identifying colors, you have learned to identify characters, you can drive vehicles. Now everything you didn't know them when you were born, right? So you train for those applications. So this is another task. So within 1 year, you can learn French. So your intelligence is trainable, right? So you are going to learn French and you can do that, right? With some dedication, with your commitment, you can do that, right? Got it? So my point was, okay, your brain, or not brain, but your intelligence, using your intelligence, you are going to do these things, several things. But these are not something that you have you inherited from your birth. No, right? You get it after training for something. Like, so you train to walk, right? You can't walk when you were born, but you train to it. And you can now identify colors, right? You can identify objects, you can drive cars, right? So all the capabilities, like, you got these things by training your intelligence. So your intelligence is trainable. What do you mean by artificial intelligence? Is specifically the human capabilities. If we can simulate, or if we can uh, build, if you can develop human capabilities in the sense, whatever the things humans are doing using their intelligence. So if machines, or if we can implement them in computers or in machines or any electronic devices, right? If we can implement human intelligence in devices, electronic devices, that's called artificial intelligence. The broad area: self-driving cars, object detection, machine translation. What do we machine translation? The Google Translator, translating one language into another language, right? Machine translation, stock market prediction, anything human can do. If a machine can do the same thing, that's the application of artificial intelligence, right? So whatever thing human are doing using their intelligence, if a machine can do the same thing, that's called artificial intelligence, right? Specifically, the things humans can do, right? So intelligence, we are going to add the noun, right? Like, we are going to add the artificial, right? So it becomes artificial intelligence, right? Now, I can show you several examples, right? Let me show you some quickly. Not here, sorry.
Take me to Starbucks in San Mateo.
I wanna live like it's Mardi Gras with a phone call and the entourage. And don't need the R&R to regular life. I say I was. Hey, living life in the fast lane. May your pain only be champagne. So please come join me. One thing, good vibes only. I just cash my check. Hey, I ain't paying rent. I just quit my job. Go to the mall, get lost. Don't care who you are. Don't care where you're from. We all got one thing in common. We just wanna have fun. Hey.
Right? So this is the NVIDIA self-driving car, which was built in 2016, right? So human capability, right? So simulate human capabilities here, right?
The official name for our car is the MIT Human-Centered Autonomous Vehicle. But amongst our team, her name is Betty, as in Black Betty. Today, we'd like to demonstrate activity recognition. Two-stream neural network, optical flow and RGB coming from the video of the driver's body. The output of the network is a prediction of the driver's activity, whether that's texting on the phone, drinking water, or playing guitar. All right. Hey, Betty, let's go for a drive.
Sure, Lex. With music?
Yes, play your theme song.
Would you like to play along?
Yes.
Ready?
Yes.
Right? So this is research done in MIT University. And let me show you another example. So you can see that it's something that we can do, right? So you can see that it is there is an object detection API, right? And that object detection API can detect almost all the objects in the frame, right? Almost all the objects in the frame, isn't it? Almost all the objects in the frame is detected. Awesome, umbrella, tie, chair. So the human capabilities, right? So human also can identify objects, right? So this is cancer detection, skin cancer detection. Okay, something that doctors can do, machine also can do that. Understood? This is what I was talking about.
Hey, Facebook friends, what's going on? Rich on Tech here, and I've got to show you an app that is just super cool. You've probably heard about Google Translate. It's been around for a while, but it recently got a major upgrade, and now it's just pretty darn awesome. So what it does is it uses augmented reality to literally let you look through your phone at something that's in a different language and translate it instantly. It's kind of tough to explain, but let me just show you. So here's the app. I've got it running on this Samsung Galaxy Note 4, and there's some signs that are in Spanish. Okay, let's say I'm in a different country. All I have to do is aim my phone at that sign, and look at that. Immediately, you can see it change right on the screen from apague telefono móvil to turn off telephone mobile. Now that's not perfect, but you get the gist of what they're trying to tell you. And the cool thing is when you look at it on your phone screen, it's in the exact same font.
So that's the Google Translator, right? Chatbots understand the language. See? Chatbots. So music generation, another application of AI. Do you know about this music generation? So now this is a music track generated by AI. I mean, a kind of a machine learning algorithm. Right? So you can see it's like a real music track, but it's artificially generated, right? So this is something that human can do, but still it can do. The computers can do it, right? So artificial intelligence, right? So now this is some application done by me, but unfortunately it's not working here. Anyway, this is also another application done by me, a web application where you can upload the X-ray image, right? And you can detect whether COVID-19 positive or negative, right? Understood? So these are few of the applications, right? But still, can you understand the importance, right? Understand the importance, important in the sense like those are the applications of AI. So all the applications that I showed you, humans can do that, but now also machines also can do that. So those are called artificial intelligence, right? Applications of artificial intelligence, right? So then what do you mean by machine learning? So you can see clearly machine learning is a subset of AI, right? A subset of AI. That means it's a part of AI, right? What do you mean by machine learning? When it comes to machine learning, you have to keep 3 points in your mind, right? Machine learning is about the practical part of artificial intelligence, right? The practical implementation part of artificial intelligence, right? So AI can contain lots of concepts, but the practical implementation of artificial intelligence is known as machine learning. And when it comes to machine learning, you have to keep 3 things in mind. Machine learning is about compute algorithms, right? So machine learning is about compute algorithms. So in machine learning, what you find is compute algorithms. And these algorithms can be trained for a specific task. For example, it can be trained for, we can take a machine learning algorithm and we can train it for a self-driving car. We can take a machine learning algorithm and we can train it for image detection API, right? Object detection API. You can take a machine learning algorithm and you can train it for stock market prediction, right? So the second point is these machine learning algorithms can be trained for a specific task. And the third point, after training it, you can use it to get future predictions. You can get it for future predictions. 3 points. Computer algorithms, trainable computer algorithms. They can be trained for a specific task. After training, you can use it for future predictions, right? For example, you can build a stock market prediction app, right? You can train it. We can train a machine learning algorithm for stock market prediction. And thereafter, what you can do? You can simply, do future predictions, right? So you can convert it to a mobile app, and you can right, so you can upload it to Play Store, so you can do future predictions, so they can download and they can do future predictions, right? Self-driving car, you can take an algorithm and you can train it for self-driving, and after training it, you can run it, you can drive it in the road. So future predictions. Got it? That's what you mean by future prediction. So this is what about machine learning. So when it comes to deep learning, so you can see deep learning is a subset of machine learning. Another subset, another kind of narrowed down part, right? So what I mean by deep learning? Deep learning is a high level version, a complex version, an advanced version of machine learning. A high level, advanced, and a complex version of machine learning. So in deep learning, what's the difference between machine learning and deep learning? If you compare machine learning and deep learning, simple. The same idea is there. Machine learning also, you have trainable algorithms and they can be trained for a specific task and they can be used for future prediction, right? The same idea is there, right? No difference, the same idea is there. Deep learning also, since it's the subset of machine learning, there are trainable algorithms. They can be trained for a specific task and they can be used for future predictions. That thing is there. But what's the difference? It is a high level version. It's an advanced version. So then what it means actually? What's the difference if you take machine learning and deep learning? Yes, it uses algorithms, but deep learning uses some advanced algorithms, advanced versions of algorithms, and they are known as neural networks, right? So if you compare the machine learning and deep learning, the difference between machine learning and deep learning uses algorithms, but those algorithms are known as neural networks. So neural networks are a bit advanced algorithms, right? So what are the algorithms that used in machine learning? What are the algorithms that used in machine learning? They are called low level or middle level algorithms, and they are kind of traditional algorithms like clustering algorithms, classification algorithms, and regression algorithms. We have lots of algorithms, but they are a bit old and they are low level and middle level algorithms. When it comes to neural networks are very sophisticated and they are very high level and advanced version of algorithms. Neural networks can do lots of advanced tasks. For example, you never train a machine learning, you can't never train a machine learning algorithm for self-driving, since the machine learning algorithms can't solve that kind of complex problems. But you can train a neural network for self-driving cars, right? That means for advanced applications, advanced implementations, we have to use deep learning. So deep learning is the advanced version of machine learning, which use very powerful concepts and very powerful algorithms called artificial neural networks, right? We have a question, let's see. More layers. No, not exactly. We don't have any layers in machine learning. No, we don't have any layers in machine learning. Machine learning algorithms are not about neural networks, right? If you take pure machine learning, nothing related to neural networks. No, neural networks will be there found only in deep learning, right? Got it? Understood? Yeah, exactly. Hidden layers in deep learning. So yeah, when you have more hidden layers, you can achieve more complex. You can solve more complex problems, right? Okay, so that's the difference between these three. So another thing, one last thing that we are going to discuss. So we are not going to focus on deep learning in this course, but we have more workshops coming in the future. In that case, you will learn about deep learning in those workshops. We will inform you about those things. And we have three main categories under machine learning, right? The last thing that we are going to discuss today. In machine learning, we have three main categories. We can divide machine learning into three: supervised machine learning, unsupervised machine learning, and reinforcement learning, right? Supervised, unsupervised, and reinforcement. And in this tomorrow session, we are going to focus about supervised machine learning, right? So I will stop it from here, right? I'm not going to discuss further. We will start it from here tomorrow, and we will continue the session tomorrow. We'll start tomorrow at 4 p.m. and we'll go up to 7 p.m. Right? Okay. So any question from the sections that we have covered today? Do you need to get any clarification or anything to be discussed again? Any questions you may have? Okay, I think it seems and no questions are there. So let me conclude the session for today, and we will meet on the last day tomorrow, and we will discuss about the remaining part of machine learning, and also we will discuss about the deployment of machine learning models in mobile applications and web applications on tomorrow. So thank you very much and have a good night.